Hey guys, welcome back to Monica Custom Guitars. Welcome back to my channel. And today I'm going to start talking about the neck machining for the Nocturnal 7-string guitar build. Now, if you remember a couple of videos ago, I disassembled this particular guitar, which was an old 7-string that I built many years ago. And the parts that I took apart from the guitar, I'm going to reuse them and creating a new design, which in this case is this one, which I called the Nocturnal. So let's roll the intro and we can begin. Okay, so when it comes to machining a neck blank, I like to divide the process into three parts. First part would be the truss rod. Then after gluing the fretboard, the second part would be start machining the back of the neck. And the final part would be machining the top side of the neck. But before I start machining, I need something to align the blank on the CNC bed. And to do so, I usually glue, well, if you see, the neck is already done. And to align the blank on my CNC bed, I use a 4-pin method. And that's where these little tabs come in place. I glue these tabs on the blank just to allow enough width so I can drill holes for the alignment. In fact, these have multiple holes because I use them multiple times. And these holes will help me to align the blank on the bed. And then when I'm done machining one side, I can flip the blank and install the pins. And I would have the blank in the same Y and X point. And that's very helpful when you're doing when you're machining from both sides of the blank. So the truss rod is divided into two operations: the channel itself and the part where you put the Allen wrench through to adjust. And those are two different parts. Now for the channel, I use a contour operation on Fusion. Don't ask me why I don't use a pocket, because I don't remember why, but something didn't work, and the contour operation works really well. But for strange reason, Fusion, if you have a channel 6mm wide and you're using a 6mm cutter to route out that channel, Fusion doesn't generate the toolpath for some reason, I don't know why. So in order to go around that little problem, I do my channel 6.1mm wide instead of 6mm. And in this case, I can compensate if the truss rod had some thick welding. I have a message. I was saying this works good because sometimes my truss rod have some big tacks of welding, and that 0.1 really makes a lot of difference. And with a 6.1mm channel, I can easily use a 6mm cutter, and yeah, I use a contour operation. I go around 1,500. Originally it's 1,500 millimeters per minute on the feed rate, but sometimes I bump it up to 2,000, the maximum speed that my CNC can do. And I use a 2mm depth of cut. Now, for the forward part of the channel, which where is visible at the headstock. Since it's coming, I usually design it to come as a slope instead of a straight line. In this case, I use a parallel operation, so the bit will move along that contour, and I'm still using the same 6mm flat cutter because I don't like to have a half round channel. I always like to have a flat bottom channel, and that's why I still use this same 6mm cutter. Now with that done, it's time to glue up the fretboard. Unfortunately, I don't have any footage for that matter. It's just a piece of wood with some glue and some clamps on it, and that's it. I mean, I believe you've seen a lot of people gluing up fretboard, so I didn't bother to just film it. Actually, I forgot to film it, not I didn't bother, that's different. But anyway, I digress. Okay, so after the glue is set, it's time to start machining, finally, the actual neck. Let me see my notes. And first, I like to start machining the back side of the neck. Don't ask me why, because everyone works differently. That's how I like to do it. Now, for each operation, I mean operation back side, front side, I divide the whole operation into 3 different segments. The small tool pads, roughing tool pads, and finishing passes. Now, what are small tool pads? Small tool pads are, well, in this case, the tuners, the hose for the tuners, the hose for the threaded insert, and some miscellaneous tool pads. For example, in this case, it has a small decorative cutout in the headstock. And roughing tool pads are, as the name suggests, clearing material as much as I can. Roughing tool pads, as the name suggests, is a roughing pass to clear as much material as possible, leaving just enough for the finished passes. Okay, so for the tuners and for the threaded insert, I like to use a bore operation. I'm still using the same 6mm bit. It's just a normal 6mm router cutter, no fancy downcut or upcut at this point. And after that, I have to mill that little cutout from the headstock part. And in this case, I've used a contour operation. Don't ask me why, but it should be a pocket operation to remove material. But for some reason, I did use a contour, and it wasn't good. I mean, it did the work, but later on it will bite me in the ass, because I think I got it in camera, it flew away. I did change it later on in Fusion 360 and regenerated the tool pad as a pocket, but at that point I didn't bother to do it. I was lazy. So I let it be as it was, a contour operation. It was cutting. It cut the contour of it, but it should have cleared material even from the middle. Okay, so let's start talking about roughing passes. For the back of the neck, I have 2 roughing passes. One is the profile of the neck, the parameter of the neck, and the second one is clearing material from the contour or the shape of the back of the neck. For both cases, I use one particular bit, which is a 10mm roughing bit. It's very aggressive. And why 10mm is because 10mm is the maximum, is the thickest bit that my spindle can take. Okay, now for the tool pad, again, I'm using the 10mm roughing bit. I'll go full speed with my CNC, which is 2000 millimeters per minute on Mach 3. And I use a 2mm depth of cut. A little side note, I like to create tabs for this tool pad, and these tabs are located precisely at a specific points. I choose them, and they are at a specific height, because in the headstock area, I have 3 here, and if I leave them, for example, 5mm, when I'm leveling the headstock from the front, 5mm won't be enough. So that's why they are at a specific height. And at the back, I have 2 more, and these 2 are specifically located between 2 frets. And that is very important because, again, when we talk about frets, I explain you exactly why. So yeah, that's very important. And again, this is my workflow. I mean, they might help you out, they might work for you, but this is what works for me. Okay, so now it's time to remove material from the back profile of the neck. And again, in this case, I'm using the same roughing bit. I'm using a 3D pocket clearing operation for this particular task at hand. And I just select that face. Now, I'll go, again, full speed on my CNC, 2000 millimeters per minute, and I use a 2mm depth of cut. And leaving, I think it's 0.5mm of material for the finished passes. Okay, so now for the finished passes. Now, for the finished passes, like the roughing, I have another particular bit for this case. For the contour of the neck, I use a 3/8 downcut, spiral downcut bit. Since I need the exact locations for the tabs, what I do is I duplicate the roughing pass and I just change the bit, change the cutting parameters, and I dechecked the leaf material. And that's just because to keep the same tabs in the same location. And for this tool pad, again, I go for speed with my CNC, and instead of 2mm, I go a little bit more, 3, sometimes even 4, but in this case, a 3mm depth of cut. Now, for the final pass, and then we can flip the blank over, is to finish the profile of the back of the neck. Now, for this, in the beginning, when I was doing neck blanks on the CNC, since it's kind of a 3D area, the profile, I was using a parallel operation, and it worked great. I mean, I didn't have any big issues with it. The only complaint that I had is the parallel operation. It always starts from the edge to another edge. And at the edge of the neck, there will be a lot of material instead of the center. So I would have the bit plunging in most of the material, and I didn't like it at that time. I tried to make it start from the middle, but I couldn't figure it out, if it even possible. And this was a couple of years ago. Maybe now it's updated and there is something. But experimenting with different type of tool pads, strategies. Let me see what the name it is. Yes. I discovered that the scallop operation works really wonderful in this case. Now, what does the scallop do? Scallop operation, you can make it start from the middle and going outwards of the blank. And when it comes to the volute of the headstock and at the junction where the neck heel is, the parallel operation, it will go in a particular angle. I mean, if it's set up at 90 degrees, it will go straight in parallel with the neck. But the scallop, it's a combination of both, going parallel and cross. So in the middle, it will go alongside the neck, and when it comes to the volute near the headstock and near the joint of the heel, it will go across. It will follow that particular contour. And that is really beneficial later on when you're going to start sanding, because tool marks are barely visible with the scallop operation. Now, at this point, I'll go with, let me see, if I'm not mistaken, 0.5 millimeter step over with the bit. The less step over you have, the better will be the final cut. But the less step over you have, the longer the tool pad will be. So there's a little bit of either this or either that. Anyway, 0.5 to sometimes even 0.75 millimeter step over. It works great. And again, couple of, and again, some sanding and the tool pads are gone. Okay, now it's time to flip the blank. At this point, I like to start removing material from the headstock. And to do so, I use my 10mm roughing bit. It's a 3D pocket clearing operation. I just select that face. I'm using my 10mm roughing bit. I use a 2mm depth of cut and full speed on my CNC. And at this point, this is where that thing, that little cutout for the headstock, bite me in my ass, and this is where, I don't think I got it on camera, it might be, I'm not sure, I need to check the footage. This is where that piece flew away. Until today, I haven't found where that piece went. probably some in another dimension, something like that. Anyway, I digress. Let's continue. Okay, after that, with the same bit, I will remove some material from the fretboard. As I said before, my fretboard blank is 8 millimeters thick, and the end result, the end thickness of the fretboard would be 6.5. So I have some material to remove. In this case, I'm using a parallel operation since the fretboard is radiused. And since I don't have much material, I'll do this in one pass. After that, it's time to start the finish passes. So I change to the 10mm ball nose cutter, and I start finish the fretboard. Now, since I don't have much material to remove, since I finish pass, I'll go full speed with my CNC, and it's very important, the step over rather than the depth of cut. So between 0.5 and 0.75 millimeter, the step over that I choose. In this case, I think I used a 0.75. It's a 20-inch radius, just to let you know. And it went really well. I mean, there isn't much visible marks, but it might need some sanding after for sure. And with the same bit, I need to finish the contour of the headstock. Is this part of the neck. And for that, I'm still using the 10mm bull nose cutter. And since it's not a big area, and that part is quite tedious to sand, I like to lower the step over for the bit. In fact, I think I use a 0.1 or 0.5. I need to check. But yeah, since it's a short area, you can lower the step over and you're going to have a better finish, and you're going to minimize sanding later on. The inlay. Before I go with the frets and nut, which is almost the only thing that's left, I need to cut the inlay. I'm not going into details about inlay cutting, because I think that deserves a video on its own. But before I continue, I need to do the actual pocket for the 12th fret inlay, and in this case, that inlay, that pocket, is made out of 4 operations. As I was saying before my camera battery died, the inlay pocket consists of 4 operations. 3 clearing operations and a finish pass. The first three operations are pocket operations, 2D pocket, and I'm using a 3mm cutter for the first one to remove most of the material, a 1.5mm cutter to remove the rest of the material, and then with a 0.8mm cutter. And in the last two, I use the rest machining. I checked the rest machining tab, so the following toolpaths will just remove material which the previous one didn't remove. And for the final pass, I use a contour operation, and I'm using a 0.5mm cutter. And again, I have the rest machining tab checked, so it just removes material that the previous bit didn't remove. So now it's time to talk about the frets and the nut. Now, this operation can be very daunting for some. I know it's for me. And it can be either a very time-consuming toolpath or a very expensive toolpath. Now, what I mean by that? You can be conservative with your feed rate and depth of cut, and you're going to have an hour-long toolpath, or you can go hard on your feed rate and depth of cut and having a 20-minute toolpath, but risking of breaking a lot of bits. And the bits that I use are €5 each. If you break 4, it can be quite expensive. I'm still working for a perfect recipe for this toolpath. I didn't actually dare yet, but as a guidance, I use a 300mm per minute feed rate and 0.25mm depth of cut, and I put the spindle at high speed, the maximum it can go. It goes 25,000 RPM, so I put it on high. In the beginning, I was doing 0.5mm depth of cut, same speeds, and I was breaking a lot. So now, with a 0.25, it's much more it's much more gentle, but it takes a long time. It takes over an hour to finish all the frets. And I usually go 2.25 deep into the fretboard. Yeah. Now for the nut, it's a simple contour operation. I use a 1.5 cutter. I use a contour operation because I like to design the nut wider than the neck. So the bit will follow that contour and it will go all the way in the pocket of the nut. And that is how I'll do my machining for neck blank. It works. That's what works for me. That's my workflow. It doesn't mean that it will be your workflow or that will work for you. You might benefit from this, from my tips. You might have a better option. If you have any questions or comments, please leave them down in the comment section down below. I'll do my best to answer them for you. If you want to see more of Micro Custom Guitars, down in the description below you'll find links to my other socials. And if you want to support my channel, you will find means and ways to do so. If you like this video, please hit the like button, share it with your friends. It will help this channel immensely. If you're new to the channel, you're enjoying what you see, please, I invite you to subscribe to my channel and hit the notification bell so you will be aware about my future releases. I'll do CNC and guitar building related content. And guys, until the next time, take care and goodbye.